Hello, welcome to Section 8 of Unity, Materials and Lighting. Now this is a pretty big and complex area of game development and of game coding, so we're only going to give it kind of a cursory look, how do lights and materials work and operate inside of Unity. It's a huge part of computer graphics, and it's a huge part of real-time development, and so it's so big we can only really look at a few small things. So the first thing I'm going to run you through is just the basic concept of lighting in Unity. And let's just turn that down for a second. In order to do that, one of the things that I have to show you is this lighting dialog. Unity has a brand new Unity 5 I'm talking about. It's a brand new lighting schematic and real-time light baking system. It's actually pretty deep. Like I said, we're not going to spend too much time on the whole baking of textures. We're not going to really look at that at all. We're going to look at the dynamic lighting system. So what I want to go over right now, just to introduce, before we even get to materials, I want to introduce the concept of lights in Unity and how they work. And they're very similar to every other 3D package, with the caveat that it's all happening in real time. Alright, so this lighting dialog here, you can go to Window, Lighting, and if I can find that here, there it is. And it should pop up, and you can float the menu, of course, if you choose. And this little docking system, I like to chop it down here, just because it's more of a landscape than a portrait type of scene. So we can do it per object. We're just going to look at the scene, and we're really going to look at here is our environment lighting. This is the only thing we really need to worry about right now, and this is what's called ambient. So the first light we're going to look at and just understand is an ambient light. An ambient light is light that comes from all directions at once. And in Unity, they have something called global illumination, which we're going to get to in a little while. But what I want to do is just say if I have an ambient light, right, it's going to light my scene whether or not I have any lights in my scene. So if I have no lights right now, I have no lights active, and I have no ambient light, it's going to be completely black, all right? So this is just how our global illumination works. And the thing about global illumination is that no matter what lights you have, it kind of bounces around and lights up everything from every direction. And a lot of the 3D packages, if you just have one light, it doesn't light up everything from every direction, and the light doesn't simulate the bounciness. And what Unity's done is created a really nice way to create what we call ambient global illumination. So I'm going to turn up my ambient intensity, and you can see I've got a kind of shine happening here, or my colors are popping out from my ground, my object. It's ambient, which means that it doesn't have shading, it doesn't have light and dark areas. We need a direction for the light to come from in order to get that. So the ambient color, and I'll show you how this works later, but we're going to not turn it on right now. And just know that the ambient color is there as a possibility. And here's the actual ambient color. And I can use various things to get my environmental lighting and my ambient set correctly. So now my ambient color is going to be mixed in with all the colors from the materials and things. So now it's just a white color. So this denotes the actual color. So I can even say, all right, well, I want it to be red. If I have some kind of red dawn, I can do a lot of effects with this. But generally, we're going to keep it somewhere in the middle as in grayscale value. And it's asking me what the source is for my ambient. So right now, I'm giving it a color. We can also do gradients. There's a lot of sophisticated stuff that can happen with ambient color. And we're not going to get into that as much as we're going to get into just the basic lights. So that's why I chose color. So an ambient color of gray is going to mix in with the colors of the materials that I have. And what I'm going to do is I'm going to turn this off completely. I don't want any ambient light at all. And we'll see later on when we get to global illumination how that's going to mix in with the rest of our scene. Alright, so let's look at our first light type in Unity. And if you do a lot of 3D development and content creation in something like Maya or Blender or 3D Studio, you're used to these lighting, these different types of lights and these lighting parameters. So first of all, now I've got these objects here, and I can turn on and off the activeness of a game object by clicking the checkbox over here. So when I uncheck it, it's still in the scene, but it's basically inactive. It's not working. So I'm going to set this on, and let's look at our directional light here. Now I'm going to bring it up in space. All right, so what a directional light is it's a light that shines light infinitely in only one single direction. Right, so you can see the direction it's going. So it doesn't matter where in space it is, because this light's coming from everywhere. It's coming from every angle possible, but only in one direction. So the position of this light does not matter at all. However, the rotation of the light matters a lot. And you can see as I change the rotation of my light, it changes the direction the light beams are being cast in. Now, directional light is an awesome light to simulate the sun. Why? Because the sun is so far away from us, pretty much all of the beams, and it's so much bigger than the Earth, all of the beams of the sun hit us at the same angle. It's not like it's a point in space, like a light bulb. And we're going to look at a light bulb light in a second. So this is a good simulation of the sun. When you do outdoor lighting, you always start out with one single directional light. Now, what are some of the problems with the directional light? Well, you have this area here on the other side that's completely dark. Right? Now, how do we brighten up the backside? Well, we could create a bunch of other lights and things like that, but one of the things that is nice is that we have this ambient intensity. So now I turn on my ambient intensity here, as we were just talking about it, and boom, it actually brightens up the other side of my object, and even the shadow it casts a little bit. Right, and so it looks more realistic to actually have the light bouncing around a little bit. So I'm mixing my ambient intensity. And we can see that it brightens up parts of the object that aren't directly being illuminated by my light. Now, let's look at our light parameters. So here's my directional light. Here are the things that we can change about it. We're not going to worry about baking at all. We're always going to leave this on real time. We want to deal with dynamic lighting. And dynamic lighting is lighting that's changing while you're looking at it. Non-dynamic lighting is baked into the texture and into the 2D part of the material. So baked lights happen a little bit differently. All right, so we can change the intensity. How bright is this light? It's no intensity. We're not going to see any of the light at all. And 1's a good starting range for a light. We obviously can change it to anything we want. Let's leave it at 1 though. Alright, now what is this bounce intensity? That's how much of the light bounces off other surfaces, how bouncy the light is. We're not really going to mess with that too much. That gets into some pretty complex parts of what's called global illumination and radiosity. Alright, so let's look at our shadow type. Right now we're casting a soft shadow. Now, a soft shadow is based on usually what we call depth maps. So we use 2D texture information to cast those shadows. If I change this to hard shadows, you can see that I get a crisp edge. Now, when do we want hard shadows and when do we want soft shadows? It just depends on the lighting situation. If you have very harsh, stark lighting, you may want a hard shadow. If you have a lot of lights in your scene, you might want somewhat of a blurred shadow, and we can blur it around the ends. We can change some things like the bias, and let's just say, yeah, we can change the strength here. So obviously we want there to be a shadow, but if the shadow is completely black, sometimes it doesn't look quite realistic. So I can turn the shadow strength to all the way on, which is as dark as it can get, or maybe it's say halfway, and then we can kind of lighten up the shadow a bit. Now we can change the resolution of our shadows. And the bias will basically change how that shadow is calculated. So we have changed the bias a little bit occasionally. If you notice, if your bias is off, you'll see this streaking everywhere. Well, that's just because the bias is not high enough, normal bias, to get a smooth interpolation of the shadow. And usually we leave these alone unless we need to change them. Alright, so those are the shadow parameters for our directional light. Now let's look at a different type of light. So let's just turn that directional light off. And now let's bring up a point light. Alright, what is a point light? A point light is a light bulb, right? Instead of being all the beams of the light happening from one point in space, but I'm sorry, from every point in space at the same angle. Now we have a point in space emanating light in multiple angles. So we had multiple rays in one angle with a directional light. Now we have multiple angles in one point in space. So that means when I move this light around, it dramatically changes. Let's turn the intensity a little bit. It dramatically changes the angle of light. Now, this is a light we want to use for a torch or a light bulb or something that's a single point in space giving off light. So a light fixture, a light bulb, or a torch, or some individual point in space, a candle, whatever, that's where the light's going to come from. And you can see as you move it around, some guy was walking around with a candle, you can see that the shadows and the angle of the shadows it casts are going to change. And that's a really important thing when you're dealing with dynamic light. We want the lighting to change if the source of the light is moving, right? So that's why we use this point light for things like a flashlight, or we'll get to what's better for a flashlight in a second. But if we want to use a candle or a light bulb or a lantern or something where we have a single point in space giving off light, we use that. And it's pretty much the same parameters as the directional light. If you rotate it, however, just in contrast to the directional light, it doesn't do anything at all. It won't change it because it's emanating light out in all angles at once, so the rotation of this does not matter. Alright, now let's turn that off. And let's get to our third main type of light here. And that is a spotlight. Alright, a spotlight, we're all pretty familiar with this. And really, spotlight is a point light, but cut off to only a certain angle. So you can see the spotlight has an angle, right, which is the angle at which it's cut off, so it actually creates a spotlight appearance. And it's got what's called a range. So the range is where the light falls off. So we can say that the light, as it gets further away, has a fall off. And so I don't omit anything. The point light also has a range. Our point light, select the spotlight. Our point light has a range, so we can have what's called a fall off. So if the light gets further away from the source, if we're outside of that range, it will fall off from the midpoint, which is the main part of the range, to the point outside the range. If we don't want it to fall off, we can just make the range really high. And you can see it will illuminate as far as I want it to go outwards. We really do want the light to kind of fall off over time. And so we have that value with both the spotlight and the point light, because they're essentially the same thing. It's just that the spotlight only casts light in a single cone, right? We've limited the amount of rays. We've limited the angle of rays that are coming out from it. And spotlights are great for spotlights. They're great for things like flashlights. They're great where any source of light is contained inside of an object where it's going to occlude the light outside of a certain angle. All right, and you notice that we can see stuff outside of that because of that ambient intensity. So we can turn that ambient intensity down, and then we'll only see light inside the spotlight. Alright, so that's just a quick rundown about lights and lighting and the three most important types of lights and how we look at and control some of our environmental lighting, which is mostly our ability to bounce light or create ambient light from other surfaces. And that's just to be able to brighten up your scene a little bit if you have really stark, high contrast lighting. And there's a whole lot more depth to global illumination and creating good lighting for your scenes, but this is a way to get you started setting up lights and lighting properties for your scene.